Well, I figured I'd wrap up with one more thing. After you watch the first lecture, if you'd like some practice of these concepts, which is a good idea, you should work on these concepts, work a few problems for practice. Um, Here's some problems you can try proving on your own. These things should hopefully be familiar to you, but if not, I'll happily state any definition briefly. So the first problem is prove there are infinitely many primes. So as a reminder, a prime number is a number that is divisible only by 1 and itself, and by number I specifically mean positive integer. We don't include 1 as a prime for convenience sake, so we mean any number like 2, 3, 5, 7, and so on. Second proof. Prove the square root of 3 is irrational. Irrational meaning it cannot be written as m over n, where m is an integer, n is a non-zero integer. Number 3, we want to show that the product of two even integers is even. 4, we might prove the product of two odd integers is odd. Once again, use your favorite method for these types of proofs. You might prove the product of a, I won't use shorthand, I'll state it out explicitly, of a non-zero rational number and any irrational number is irrational. Number 6, prove the sum of a rational number and an irrational number is irrational. 7, you might consider showing the formula. N squared is equal to 1 plus 3 plus 5 and so on, all the way up until you get to n minus 1. Or if you prefer summation notation, you could say the sum from I equals 1 up until n. Well, let me think about this for a second, sorry. Yeah, I'll say n, because then you would just say it's the sum of 2i minus 1, you plug in 1, it works out to give you 1. Number 8, you could show x squared is greater than or equal to 0 for all real numbers x. And if I say show, that's the same thing as prove. You gotta show it rigorously. I don't want you to just claim it for one example, you need to show it for all possible x's. You could also show n squared is greater than or equal to n for all n, which is going to be a natural number. Negative numbers, it's kind of silly, right? If n squared is positive already, based on number 8. And I think that's good enough. There's multiple ways to show these. You can use any of the proof methods that we described earlier, and try to think about which one will give you the most clear explanation. It's okay if your explanation's longer. You care about it being something that can be easily followed step by step, something that's unambiguous, and something that leads to some kind of insight if possible. If you just bury your answer in a bunch of symbols without any explanation, that's not a good proof. Thank you.